Hey, this is James T. Kahn, and we're back again for another tutorial in libGDX. I've had some requests for terrain, and since we already have a little project going here with a camera and a character, I figured it's about time to take a look at terrains next. Now in libGDX, there are a lot of different ways to do a terrain, or to create a terrain. And you could, for instance, create a terrain in Blender, and Blender has a lot of awesome tools for creating terrains. You can make some really cool detailed terrains in Blender. Then you could export that as a model, import that into libGDX. That's one way you could do it. Another approach that's pretty popular is a height map. So you with height maps, you take usually a PNG image, and it's a grayscale image, and it looks like this. And when you process this in your code, you can determine the height values based on the color values here, based on how white or dark it is. You can convert that into a height value in your code. And generally, you would create a height with height maps. You would say this is a 64 by 64 pixel file. Each pixel would represent one vertice in this case with a height map. So that's another approach. You could also do procedural terrain generation using noise generator like Perlin noise, OpenSimplex, and you can create some really awesome procedural terrains that way. But I believe in, let's walk first and we can run later. So today we're going to look at height maps, and what we're looking at right now is actually a height map test built into the libGDX repository. It's part of the libGDX tests. So we already have code to do what we need, at least partially. So what we're going to do today is we're going to take that code and apply it to the project that we already have. Then we're going to have to make some changes, some modifications, and turn it into a terrain in our project, in our test game that we've been making. Before we jump into the code, I just wanted to cover a couple quick things about height maps. The one I will be using today is from the libGDX repository. It's 64 by 64 pixels, and we're going to start with that. It's kind of a small, low-resolution height map. But as I mentioned, height map is, so each pixel is a vertex, right? So that adds up really quick. And for this tutorial, we're not, the terrain's not going to be really high resolution or anything like that. Part of the reason why we have to use these smaller height maps is that there's a limitation on the meshes in libGDX, and I think it's partly due to Java, as well as we're using short types for the indices. So we actually run into a hard limit of how many indices we can have in a mesh. And so with that being said, what we can do later on, there's ways around that where we can have terrain chunks, and we can have we can split height maps into regions, and then we can create chunks out of that. But for today, we're just going to use one low resolution height map. But I wanted to bring this up just so that after you do this tutorial, you might be tempted to try and put in a higher resolution height map, like one that's 1024 by 1024. As you can imagine, the vertices would add up very quickly. But if you also try to squish all of that into a single mesh with the code that we write today, it's not going to render properly. It might render a portion of it. But I just wanted to mention that, and down the road we might look at how to split a large height map up and split it into a much more detailed, larger terrain chunks that are interconnected. But for today, we'll just start with a low resolution single height map. All right, so let's get started. So let's take a look at where we left off, and we had this little, I guess we can call it a game here, with a little slime character walking around, and we got these boxes. So the first thing I'm going to do is we're going to get rid of the boxes now. I think if I remember correctly, we added these just to give us a kind of reference, and we're really not creating these efficiently, so it's this time to get rid of them. We don't need them anymore. And next, what we're going to do is, if you remember, we had some libGDX already has some example code on how to create a height map. So if we go over to the libGDX repository, we got a couple things here. We have that height map test, which you saw I was running earlier. And then we've got this HeightField class, which is what the height map test is using. This is a very neat implementation of a HeightField that's created and kind of given here as an example. It's in the test project, so I don't think, test modules, so I don't think you can't access it normally. We'll have to bring this code over. That's fine, because you'll probably want to modify it for what you need anyways, which was the original intention of this class in the first place. So I'm going to go ahead and let's shamelessly copy this HeightField class over to our project. And I think what we'll do is let's create a new package for our terrains. All right, there's our HeightField. And so next I'm going to grab our height. Let's use the same height map. This is 64 by 64. This is a good starting point right here. So I'll copy this. And if you don't have the libGDX repository pulled down, you know, I'll have this code available on my repository as well if you just want to go into the repository and pull this code if you're following along. And I think I had a package here named, let's rename this. I'm going to create another another directory underneath our assets. Let's just call this textures. And that's where we're going to put this height map file, or this picture. There it is. Okay. And next, we're going to start adding in some of our terrain classes, the classes we're going to need to load and render a terrain. Now, so far in this project, you know, I try to keep it simple by just putting everything in the same class. I'm not using an entity component system because maybe you are, maybe you are not. But terrain code, you know, it's going to get a little, there's a lot of code involved with that. So we're going to start creating some different classes here and separating some of that code. So we got our terrain package. Let's start by creating a new Java class, and we'll just call it terrain. This will be like a base terrain class here. And I've ran through this once, you know, on my own beforehand, so I kind of had an idea what I'm doing. But you know, I might have to look at my reference code a couple times, so bear with me and just follow along. So let's start with an abstract class, right? Because this is going to be our base class. And we'll want to implement disposable because we're going to have some things that can be disposed of. And so we'll want to define a couple different variables here. Let's make them protected. And we'll have an integer for the size of our terrain. We'll have an integer for our width. Now the width is going to reflect, in this case, it's going to end up reflecting the width of the height map image. And we'll have a float value. This is going to be a height magnitude. And because when we read the color values from the PNG file, they're usually going to be like between 0 and 1. So we're going to have this extra float here that we can customize to determine how much scale, like it's almost like a scale factor, like a height factor, to apply to the values we read from that PNG. If we want a really tall terrain, if we want the values to be very different from 0 to 1, we'd have a higher height factor. And so our terrains are going to need to have a model instance so that we can render them. And so we'll create a model instance here. And yeah, we'll want a getter and setter, or at least we'll want a getter for our model instance here. And of course, you can modify this as needed if you're using this. Okay, so we got our base terrain class. Now we're going to create a child class and inherit from this, which will represent our height map terrain. Because like I said, you can have a procedural terrain, but we're going to do a height map terrain this time around. So let's just call this, well, there we go, height map terrain. And we're going to extend from the terrain class we just created. And we'll implement this dispose method. But I think we have a model instance right now. We don't dispose that, so we'll need this later, but we don't need it yet. Okay, so next steps. We're gonna start creating our code to read, or not to read the height map, but what we're gonna need is this HeightField class, and so we're gonna call that in here. And that's that class we pulled over from libGDX that already does most of the work for us. Very handy, very useful. And let's create a constructor. So we have no argument constructor for now. I think we're going to change that here in a moment. We'll need to take in a file. We'll need to take in a way to read that that height map file. So in this case, we could take in a pixmap, and we'll also take in a magnitude value, which is going to be that height magnitude that I mentioned before. And for now, I think we're going to hard code. We'll hard code the size to, let's just start with 200, and change this as needed. The width is going to equal, as I mentioned before, it's going to actually equal the size of the image itself, the width of the image. And there's our height magnitude will equal the magnitude there. Okay, so now we want to start building this HeightField, right? And we're going to use that HeightField class. And if we take another look at the libGDX example for the height map test, we're going to borrow from this, no shame. So we're going to take this piece here, and I'll pull this over. We already have an environment and all those things, right? We just need the stuff for the terrain, and we're already passing in this pixmap as well as a part of our constructor, so we don't need that. So I think we just need this right here. We're instantiating the HeightField. Alrighty, so we got this. I think they called it what they called it, field. That's fine. We'll rename it to field here as well, so that we don't have to refactor all of this. And we should be able to make that final. That shouldn't be an issue. Okay. Next steps are we gotta convert this into a model that we can see, because if we take a look, and you feel free to take a look at this HeightField class to see how it works. But what we're doing is we got this constructor, is static true. We're passing in the pixmap file. There's a smoothing value you can set, and I think it bases off the normals. And then also we're passing in our vertex attributes. So we're going to have position in our vertices, and it's going to create the normals for us, which is very nice. It has this color unpacked. We'll see that shortly. And then it's also going to put in some texture coordinates into the vertices for us. Okay, so next step is right now that test I pulled over has the sizes are just hard coded in there. If we what we want to do is we want to apply our size to it, and we're actually going to do it slightly differently as well. So this is setting the corners, or the corner positions for our terrain, or our terrain when it generates. So what we're going to do instead is I'm going to go with. And if you look at these usually represent the 0, 0, so that's going to be one of the corners. And if we take a look, we can see all this rather than me kind of going off of memory. This documentation actually explains it better. Okay, so here we go. Corner 0, 1. Here we go. So the values of the HeightField normalized. 0, 1. Okay, the plane of the HeightField can be specified using the corner 0, 0, 0, 1, 1, 0, and 1, 1 numbers, where corner 0, 0 is a location on the grid at 0, 0. So this explains it here. I'd rather just look at the documentation and go by memory. And feel free to read through this. I read through it a bit beforehand if you want to understand a little bit more. But in this case, we're going to keep this at 0, 0 instead of I think what was going on here is just kind of trying to center it. And if we saw in that height map test I ran earlier, you could see that the terrain was shifted to be in the center. We're gonna change that though. And we're actually going to start, so our terrain is going to start at 0, 0, 0 and expand into the positive rather than be shifted into the negatives and centered and on 0, 0, 0. So I hope that makes sense. All right, so we're going to set our size here and still 0. And then we need this to be at 0 as well, because we're not going to shift into the negatives. It makes it easier for us later to not do the negative values. Apply our size, and then here we'll have the sizes so we can see how the corners are going to work out here. We're going to be 0, and then we're applying the size to each corner as needed, and then to the bottom, will this be, I guess we're looking at the image, maybe this will be the bottom right, depends on the orientation. Okay, so we've got our height map going. We've also got this, notice the magnitude value here, and it's only on the Y value for our height. So we'll just pop in our new magnitude, our parameter here instead. And now we need to take this. So this HeightField class produces a mesh, as we can see here. So we can take that mesh now, and I think in the test, they turn that mesh into a renderable, and then they just render that in a batch. But we're using GDX GLTF, and it has a scene manager. And so generally with that, you would create a scene, you'd pass in a model instance, and you'd give that to the scene manager. So we're going to do that so that scene manager can handle the rendering of this terrain for us for now, just to keep things a little easier. So what we need to do is convert that mesh into a model instance. That's our end goal here. And we can do that. There's different ways you can do it. We're going to use Model Builder. And Model Builder has these different part methods, and so we'll give it an ID of just terrain. We'll pass in that mesh file, and we'll specify the primitive types. We'll want to use triangles here for the terrain. And you can pass in a material. For now, we're just going to create a new material. We'll get into that later. And so lastly, we create our model instance based on the end result of the model builder. When we call end, that gives us a model, which we then pass into our model instance. Okay, I think we're getting somewhere here. Okay, so now we're going to actually try to render this terrain in our game. So let's go to our main class. And we're going to add some new variables for our terrain. So we've got the terrain itself, and we're going to need a scene to pass into the scene manager. We'll just call it, let's call it terrain scene. And we got rid of the create boxes method. And instead, we're going to add now a create terrain method. And I want to be able to call this method multiple times because if I'm debugging and I want to make changes on the fly to the terrain, I can do that without having to restart the entire, without restarting the entire game if we're debugging, which is very handy just to try different terrain settings, which you're probably going to want to do. For this, what we can do is we can check if the terrain is not, or if the terrain is not null. So we already have a terrain created. We'll dispose of it, and if we go back, I don't think we really did anything with our dispose method yet. So let's go ahead and add that. The HeightField has a dispose method, so we'll call that here. And I think that's all we needed to dispose of for now. So coming back, now the next step is our scene manager. We'll want to remove the terrain scene, so remove the existing scene from the terrain manager. And then we get down here. So of course this code is not going to matter the first time you call it, but if you call it again later while you're debugging, that's when it's going to come in handy. And so now we're going to create an instance of the height map terrain. And for now, so we need the pixmap data. We can do that here. Pixmap takes in, we can do a file handle. So GDX files internal. And we should just be able to pass in that path here, the textures heightmap.png. And what else do we need? We have a float magnitude, right? I'll set it to 1 for now, and then we can see what kind of difference that makes so that it makes a little bit more sense. 1 is going to be really low. It actually will probably be, let's just set it to 2. We'll also create our terrain scene. So new scene, and we'll need the model instance, right? To instantiate this scene, we'll have to pass in that model instance that we generated. And then we just should have to add the scene to scene manager. After that, scene manager should take over and render that for us after we've added it. Let's try and run this. Let's see if we get a terrain or not. Hey, we got something. All right, and you can see the terrain is really flat. And I did this on purpose so that I could show you the purpose of the height magnitude, right? Because those values, as I mentioned, when you're looking at the height map and you parse that in the code, those values are usually going to end up between 0 and 1, which is, you know, that's going to be very little difference in 3D at first. That's why we have that height magnitude class, or the height magnitude float. So let's come back. Let's try changing that. And you know what? Let's me debug this again, because I'm going to show you why I made the crate terrain reusable, so that we could do this very thing. And we can make changes to it on the fly without having to restart our game. So here we are. We have the terrain. It's kind of flat. And if we go to our render method, I'm going to add in another. I want to poll for another input here. Is key just pressed? We'll just use F1. That's fine. So if F1 gets pressed, call create terrain. So we'll destroy and recreate our terrain. I'm going to hit Control Shift F9 to rebuild, and that should have deployed the changes, or reloaded it, should I say? All right. So now when I hit F1, I should be able to get some changes here. So let's change. Now we're going to change the height magnitude. Let's make it 60. Let's do 60. And I'll hit Control Shift F9 to reload. Now I'll hit F1 in the game, and the terrain is reloaded. Look at that. And so that makes it a lot easier if you're debugging, if you want to figure out different settings for your terrain. You can do it that way. The terrain's getting clipped. We can probably increase the camera far plane. We can't really see very far right now. So that's one thing we'll probably want to do here. But hey, the terrain is rendering, which is great. So let's go and knock that out. We'll just increase this to let's do 1,000 for now, so we can kind of see what we're working with here with the terrain. I'll restart it. Okay. So that's actually coming out pretty good so far. So right now the terrain is rendering with some colors, and you probably want to add some textures to that. Right now we're going to add, we'll try adding just one texture. Adding multiple textures is a whole nother thing we'll get into later, possibly. So we might have to do a custom shader if we want to have different textures, maybe different textures, different heights. But for now, we're going to keep things simple, and we're going to try to just texture our terrain with one texture. So to do that, first let's take out the logic that's adding the color values. So that's this vertex attribute right here, color unpacked. We're not going to need that since we're going to replace it with a texture. And then this color setting here, setting these color values, we can comment that out for now as well. And now we need a texture. What I'm going to use, and you can use any texture you want. I'm just going to use a quick one. I haven't even tried it yet, but the site, free PBR, there's plenty of sites out there. Polyhaven is one that I really like. But I'm going to try this site out today, free PBR, and it's just a sand dune material. I tried grass when I was originally doing this, and since my slime is green, the grass is green, it kind of just blended in. So I'm going to try this out, a different texture. And we'll need to get that texture in our assets directory. So I'm going to open this up in so we have our textures here, and I have I got to open it still. Let me open up the zip file here for our sand dune textures. And I'm going to grab the albedo, which is going to be our color, our diffuse. Take a look at that. All right. I'm going to press F2. That's just so I can copy the name of this texture easily. And then we'll come back to the code. So to add a texture to a model, Normally we would use material, and so we're going to do the same here. So we'll instantiate the material. You know, down here we were creating it here. We could still do that. I'm just going to move it out of here. Move it out, and we're just going to call them or pass our material object in, but create it above. Okay, so we'll set a texture attribute, and in this case we're using GDX GLTF. So we're going to set a PBR texture attribute, create, and that's going to be the base color texture. And well, we can just do a new texture, and right, this takes in a path, files internal path, and like we did with the height map, textures / I copied and pasted that texture name right here. Okay, so if we're setting this texture attribute and we're passing the material in just like that without making any other changes, let's just run this and see what we get. And hey, it's, you know, we got a texture going. It's not very pretty and it looks a little strange, but we can fix that. But it's working, so that's good. We'll cancel out. And so how are you? So there's a couple things we want to do with terrains, especially texture that's repeating and it's going to be viewable from far away. There's a couple things you want to do. You want to use a midmap. And thankfully, you know, libGDX makes that really easy for us. So what we can do is move the texture creation out from here because we need to make a couple changes to it. So let's create our texture up above. Okay. And now we're going to, yes, so to use the bitmaps, first of all, there is another parameter we can pass, a Boolean, true, to use bitmaps. And we are going to set some filters as well. And for now, I'm just going to use the bitmap filters. So I think midmap, linear for both of these. And without changing anything else, let's take a look, see how it's going. Oh, I forgot. We have to pass in our texture. There we go. It looks a little better, right? So we got that mid mapping, got rid of that weird kind of grainy look that we had. It's kind of blurring it as it goes further out, and so it looks a little cleaner from a distance. So that's looking pretty good. Now there's another thing we might want to change, and it depends all on the texture you're using. You might want to change the scale of this texture. Maybe you want it to be smaller or larger scale, more stretched out or less pixelated, just depends on what you want. But let's just try that out. Let's tinker with doing that. And so that's actually done on the, I think we do that on our texture attribute itself. So we're going to have to pull this out as well. And we'll just create it up here. And so, right, to change that scale, if we want to change the scaling of that texture, we're talking about like a UV scale. And the texture attribute, I think we can change it here. Let's see, scale. Oh, I'm on the wrong one. So texture attribute. There it is. Our U scale and our V scale. We can change these. Let's now on a big terrain, you might want to, you know, change the scale factor. And again, like I said, it depends on the size of your texture, what kind of texture you have, what kind of look you're going for. I'm going to just try scaling the U and V by 50 here. And take another look. Oh, you know what I forgot? So we pulled the texture attribute out, but we got to set it. There we go. All right, so yes, it's applying the scale here. But obviously we can see there's some issues. No problem, that can be fixed. One other thing we have to do when we're changing the scale, we'll want to set wrapping on this, right? Because this is, I assume this PBR texture is tileable, where it can be repeated. We'll find out here in a minute. But to actually tell, to actually allow that to happen, that's another thing that we have to set. And that's on our texture itself. And that's setting the wrapping. So texture wrap repeat will allow us to repeat this texture. Here we go. Okay, so that's better. And you know, that texture, that scaling might be way too high for this texture. It's something you can kind of tinker with. I think the grass texture I used when I was first doing this looked a little better, but it's fine. This will do. So again, you know, tinker with that scale factor for whatever looks good with the texture you're using. Obviously, you can see right now that our character, he's not moving with the terrain. That's something that we'll do next time. But the main goal here was I just wanted to get a terrain rendering that has some height to it, and we got some textures on it. And you can play around with the scales, play around with the size as well. If we could change this maybe to 800. You're gonna get different. You're gonna get different results when you change these values. So we can see here the terrain is much larger, and of course, because of the larger scale, the height is actually kind of affected by that as well. So you could change the height magnitude. Yeah, so this is just the first video. I think what we'll do next time is try to get some physics going, or not physics, should I say, not physics. That may come at a later date, but for now we'll stick with just kind of more basic collisions. So we'll look at how to get the player to collide with the terrain and stay on top of the terrain. But I'll leave you with this for now, just to kind of get a basic terrain system going with rendering one terrain tile. I hope that was helpful, and then keep an eye out for the next video. We'll get the slime character actually walking around on the terrain next time.